Look at any helicopter and you'll notice something strange. There's a massive rotor on top doing all the heavy lifting, and then there's this tiny little propeller bolted to the very end of the tail, spinning away quietly like it's not sure what it's doing there. Most people assume it's for steering, some think it's a backup system, a few don't even notice it at all. But here's the truth, that tiny rotor is the only thing standing between a smooth flight and a catastrophic, uncontrollable spin. Remove it, and the helicopter doesn't just lose steering, it loses everything. So why does it exist, and why does it have to be all the way back there? The answer goes back to one of the most fundamental laws in all of physics. When a helicopter engine fires up, it doesn't lift the aircraft directly. It spins a shaft, which spins a gearbox, which spins that giant rotor above your head. The blades bite the air and throw it downward, and that's what gets you off the ground. But here's the problem. To spin those blades, the engine has to apply an enormous twisting force called torque through the gearbox, and that gearbox is bolted solidly to the fuselage. Isaac Newton's third law says every action has an equal and opposite reaction. So the moment the engine twists the rotor one direction, the fuselage wants to spin the other direction. Think about sitting in an office swivel chair holding a spinning bicycle wheel in your lap. The wheel spins right, you rotate left. You didn't push off anything, physics just made it happen. A helicopter without a tail rotor is exactly that. The body of the aircraft would spin endlessly in the opposite direction of the main blades, faster and faster, with the pilot completely helpless inside. The tail rotor is the solution. It's a small propeller mounted sideways at the end of the tail boom. It pushes air horizontally, which pushes the tail in the opposite direction, creating just enough force to cancel out the torque and hold the helicopter straight. But here's the clever part. It doesn't need to be powerful. It just needs to be far away, because force multiplied by distance equals torque. A modest push at the end of a long tail boom creates a massive countering twist. That's why helicopters have such a long, slender tail. It's not about looks, it's a lever. Now, who figured this out? A Russian engineering student named Boris Yuryev sketched out the exact same design you see today, single main rotor on top, small tail rotor on the end, back in 1911. He even built a prototype and won a gold medal at the Moscow Aeronautics Exhibition in 1912. But the engine shaft snapped during testing. Funding dried up, World War I started, and his invention sat untouched for nearly 30 decades. It was Igor Sikorsky, a fellow Russian who had emigrated to America, who finally brought it to life. On September 14, 1939, in a field in Stratford, Connecticut, Sikorsky lifted off in a tethered hover a few inches off the ground in his VS-300 prototype. And on May 13, 1940, it made its first free flight. By 1942, the design went straight into mass production, and that same basic layout is still the most common helicopter configuration in the world today. Yuryev had the idea, Sikorsky made it fly. Here's where it gets interesting. That tail rotor doesn't just hold the helicopter steady, the pilot actively controls it using foot pedals on the cockpit floor. Press the left pedal, the tail rotor increases pitch, pushes the tail right, and the nose swings left. Press the right pedal, you reduce thrust, the fuselage torque takes over, and the nose swings right. But here's the tricky part. Every time a pilot pulls up on the power lever to climb, the engine works harder, which increases torque, which means the tail rotor needs to push harder to compensate. So every power change requires an instant pedal correction to keep the nose straight. Climb, push the pedal, descend, ease off the pedal, hover sideways, more pedal. It never stops. Both hands and both feet are constantly working against each other. It's genuinely one of the most demanding things to learn in aviation. Now, what happens when the tail rotor fails? In 2018, a helicopter carrying the owner of Leicester City Football Club lifted off from the stadium just after a match. Moments later, it began spinning uncontrollably and crashed into the car park, killing all 5 people on board. Investigators found that a small bearing inside the tail rotor mechanism had seized. A part designed to last 2,400 flight hours had failed at just 330. Without tail rotor control, the fuselage torque took over instantly. The spin was described as irrecoverable. That's how critical that little rotor is. It's not optional, it's not a backup. The moment it stops working, the helicopter becomes a spinning coffin. Some helicopters have figured out how to ditch the tail rotor entirely, and the solutions are fascinating. Russian Kamov helicopters, like the K-52 Alligator, stack 2 main rotors on the same mast, spinning in opposite directions. The torques cancel each other. No tail needed. These helicopters are so structurally resilient that during combat in Ukraine, a K-52 was filmed continuing to fly after losing most of its tail to enemy fire. The military's famous CH-47 Chinook solves it differently. 2 giant counter-rotating rotors, one on each end of the fuselage. They've been in service since 1962, and they're expected to be flying in 2060. That would make the Chinook a 100-year aircraft. Then there's Rotor, which literally stands for no tail rotor. Instead of a propeller, it pumps air through slots in the tail boom using a clever aerodynamic trick called the Kawanda effect to generate sideways force. It's quieter, safer for ground crew, and produces almost no exposed spinning blades. And then there's the fenestron, which is a tail rotor shrouded inside a circular housing in the fin, like a small jet engine at the back. Airbus uses them widely today. They're quieter, safer, and the blades are deliberately spaced unevenly, so the noise they produce is scrambled across different frequencies. So next time you see a helicopter, take a second look at that little rotor on the tail. It's not decoration, it's not a backup. It's a 100-year-old engineering solution to one of the most stubborn problems in aviation, the fact that you can't spin something without the universe trying to spin you back. That tiny rotor, working quietly at the end of a long lever, is the only reason the whole machine doesn't twist itself into disaster every single time it leaves the ground. And now you know.